Hello everyone. Today we will study the chapter direct and inverse proportion. Now the entire chapter of proportion, there are two things which are, we have to have two entities x and y, and they can have a proportionality between them. One proportion is when x is directly proportional to y. The second proportionality is when it is inversely proportional to y. This chapter is not per se only a mathematical chapter, because this chapter has a lot of relevance in a lot of things which are related to physics, chemistry, or any other thing as well. So this entire derivation, entire idea of this chapter finds a lot of application in a lot of things in real life. But let's not worry about that. Let's only stick to mathematics for the time being. So we have only, let's say we are talking about something like when when I pay when I take a loan of rupees 500, and we agreed that I'll be paying 5% interest on it. So the interest that I pay in 1 year is proportional to the loan amount, is proportional to the principal amount. So if I take 500 rupees, I pay interest equal to 25 rupees. But if I take a loan of 1000 rupees, then I will have to pay the interest of 50 rupees. If I take the loan of 100 rupees, I will have to pay the interest of 5 rupees per year. Now here what is happening is, if the loan amount or the principal amount is doubled, like 500 has become 1000, if the principal amount is doubled, the interest is also doubled. If the principal amount has become 1 by 10, the interest has also become 1 by 10. So whatever be the multiplicating factor to the principal amount, with the same multiplicating factor, the interest is also multiplied. When this happens, we say that the interest is directly proportional to the principal amount. So I is proportional to P. The idea of direct proportion is whatever you multiply to one quantity, the same factor is multiplied to the other quantity. If you divide by 2, even the other factor will be divided by 2. If you multiply principal amount with 10, the interest will be multiplied by 10. You divide the principal amount by 10, the interest will be divided by 10. When this happens, then we identify that the given quantities or the given entities are in direct proportion. If the two quantities are in direct proportion, if we know that it is a direct proportion, then the obvious fallout for this is, suppose I write that x and y in direct proportion. If x and y are in direct proportion, then x upon y is equal to constant. Example, if the speed is uniform, then in 1 hour a car can travel 60 km. That is when the car is traveling, it's at the same constant speed of 60 km per hour. It's a long, isolated, good, beautifully conditioned highway with very minimum, divergence there. So as a result of that, you can afford to go at a constant speed. You don't have to worry about anything else. There is no signal, there are no pass-bys, there is no one to obstruct your way. You can go at the same speed. So if that happens, in 1 hour you travel 60 km, in 2 hours you will travel 120 km. So the necessary condition, that if one quantity is doubled, the second quantity is doubled as well. The necessary condition is satisfied. You can check that the ratio is constant. Distance upon time is 60 in this case. Distance upon time is 120 upon 2 is 60 again. The ratio will remain the same. So if the two quantities are in direct proportion, their ratio is constant. Problem is, we can take this problem. So what will be the time required to travel 300 km, and if the time is 7 hours, what will be the distance traveled? And let's solve this problem. So because we know that it is a direct proportion, as a result of that we will say that distance upon time is equal to constant. And if that happens, then we'll say that 120 upon 2 is also equal to 60 upon 1, by the way, but then 120 upon 2 is equal to 300 upon x. And then just cross multiply, we will get the answer. This is 120x is equal to 600, and divide x will be equal to 5. So it takes 5 hours to travel 300 kilometers. We know that the speed is 60. To cover 300 kilometers, you need 5 hours. The second, what is unknown here? Y. So I'll write 120 upon 2 is equal to y upon 7. Cross multiply. Y is equal to 120 into 7 upon 2 is equal to 420. 420 kilometers is the distance travel. We can check that. It is, if the speed of the car is 60 kilometers per hour, then in 7 hours, it will travel say 420 kilometers. So this is about direct proportion. There is nothing difficult in direct proportion. It is just the only critical thing is identification. Can you identify? Can you check? Can you judge if the given two entities are in direct proportion or in inverse proportion? If you can make that out, solving the problem is an absolute cakewalk. To be honest, this problem deserves to be in grade 6. It's just that we have to make a decision about if the two entities are in direct proportion or in inverse proportion. And this judgment has taken this problem in grade 8. Solving the problem is not a problem of grade 8 at all. It's just the judgment part, that is why this chapter and this problem is in grade 8. We'll now solve something based on inverse proportion that will complete our entire discussion. So while I'm recording this video, we have one more maths teacher here, and he also has recorded his video. So let's say we were going to occupy 30 minutes for this recording. If I was the only one here, then if there is one person recording, then if I was the only one, I would take all 30 minutes to record my video. But because we have two maths teachers here, so if there are two persons recording the video, then we will have 15 minutes each. I will record my video for 15 minutes, the other maths teacher will record his video for 15 minutes. What is happening here is the amount of available time, the amount of available space, the amount of available resource is limited, and it is then shared. The more number of people to share, then the amount of time, the amount of space, the amount of resource that is getting, that one person is getting, that goes on reducing. Their product is constant. 1 into 30 is equal to 2 into 15. But if the number of people become double, then the amount of time will become half. So what is multiplied here will become divided, will become division on this side. If that happens, then their proportion is inverse proportion. What is multiplied on this side is divided on this side. So that becomes inverse proportion. The other example can be if there are 4 dosa in the house. If there are only 2 people to eat, so 2 people to eat the dosa, and there are 4 dosas, so everybody will get 2 dosas each. But if there is only one person to eat, then he will get all 4 dosas. And if there are 4 people to eat, those dosas, then everybody will get 1 dosa each. Here, when the number of people was half, the amount of dosa available was doubled. When the number of people was doubled, the amount of dosa, the number of dosa was half. This is what is called as inverse proportion. In inverse proportion, if you notice that 2 into 2 is 4, 1 into 4 is 4, and 4 into 1 is also 4. The multiplication will always be constant. Like in direct proportion, the ratio will be constant. In inverse proportion, the product will be constant. There is hardly anything that we need to worry about while solving these kind of problems. It's just about, let's say, I'm going from city A to city B. The distance from A to B is, let's say, 800 kilometers. So if I travel at the speed of if I travel at the speed of 40 km per hour, then I will take 20 hours to reach the distance of, to cover the distance of 800 km. But supposedly I travel at 50 km per hour, I take 16 hours. If I travel at 100 km per hour, I will take 20 hours. If I travel somehow at 160 km per hour, then I will be reaching in 5 hours, and so on. This is, sorry, this is 8. Here you can check that the product 40 into 20 is 800, 50 into 16 is 800, 100 into 8 is 800, 160 into 5 is also 800. This 40 has become 4 times here. So the amount of time has become 1 by 4 times. 50 has become doubled here, so amount of time is half. This is inverse proportion. Now what can be asked is, what will be the speed, let's say speed is x, when the amount of time taken would be 4 hours. So if you want to travel the entire distance of 800 km in 4 hours, so we have to have, the product is constant. So what is the product in the first case? 40 into 20 will be the product in the last case as well, is equal to x into 4. So x is equal to 40 into 20 upon 4. So this is equal to 200 km per hour. We are talking about some kind of plane or an extremely super fast train which will travel with this speed, but will cover the distance of 800 km in exactly 4 hours. The second problem can be, what will be the time required if the speed is, what do you say, 80 km per hour. So we can solve it this way. Again, the product in an inverse proportion, the product is equal to constant. So I'll write 40 into 20 or 50 into 16, whatever you want to write. The product in the first case 40, 50 into 16, I'll take second case. This product is equal to the last 80 into y. So we'll write y is equal to 50 into 16 upon 80. 0, 0 gets cancelled, 8 ones are 8 twos are, this is equal to 10 hours. And not surprising at all, because if you travel at 80 km per hour to cover 800 km, you need 10 hours. This is what this chapter is about. You can solve the worksheet, you can solve this problem, but the entire thing you need to do is just have the sensible assessment of the given problem. Are the two entities given, are they in direct proportion or are they in inverse proportion? If you can make that out correctly, you should not miss a single mark in this chapter. I hope this works well. I hope it benefits you. All the best.